Hello students, welcome to Bright Minds Academy Goa. This classes are going to be for Goa Board class 10th maths, and we are starting with the first chapter, real numbers, today. So, when I say numbers, definitely what comes to your mind may be 1, 2, 3, 4, so on. Now these numbers that naturally come to your mind or that you find in nature, they are called as natural numbers. And we denote natural numbers by the capital letter N. Now next scientist said, as our Indian scientist Aryabhatta, he discovered 0. So then we add 0 to this set of numbers and we get 0, 1, 2, 3, 4, 5 and so on. This set of numbers are called to be whole numbers. Now next, mathematicians thought that since there are positive numbers, there are going to be negative numbers as well. So we have -3, -2, -1, 0, 1, 2, 3, ... on both sides. These are going to be called as integers. And we're going to represent this by the letter Z. Then the next thing that we have is, what if we divide a number 1 by 2? I know I'm going to get 0.5. Now look here. This, if you see, this is a number that these are two integers that I have taken right here, integer 1 and integer 2. So when I divide an integer p and let's say another integer q, this sort of a number is known as a rational number. But what is important here is the denominator q should not be equal to 0. So what is a rational number? A rational number is any number which can be expressed in the form of p upon q, where p and q, they are both integers and q should be not equal to 0. Now any number that cannot be expressed in this form is going to be called as an irrational number. By the way, we denote rational numbers by the symbol q. Now, as I said, irrational number, you cannot express them in the form p upon q, where p and q are integers. Now we look at a couple of examples. For example, if I have √3, this is an irrational number. We have √2, this is also irrational number. We have pi, which is again irrational. Now by the way, pi is actually not equal to 22 upon 7. This is, pi is approximately equal to 22 upon 7. Okay, you might say, why is √3 an irrational number? Because √3 can definitely be written as √3 upon 1, right? Then why isn't it an irrational number? Because the condition for it to be rational is both the numerator and the denominator, they have to be integers. Now the thing here is, √3 can definitely be written as √3 upon 1, but √3 is not an integer, therefore √3 is not a rational number. Now that we have gone through real numbers, whole numbers, integers, rational, irrational numbers, if you combine everything together, you take a giant pot, you put natural numbers here, you put whole numbers here, you put rational numbers as well as irrational numbers here, and you put integers, you put everything together, all these numbers are going to be called as real numbers. So what does real numbers include? Real numbers mostly include, you have your total rational numbers plus your irrational. That will give you real numbers. This we're gonna learn something known as the fundamental principle of, or rather the fundamental theorem of arithmetic. Now I'll just quickly write down the statement of this theorem and then I'll quickly explain you what this theorem means. Now the statement for this theorem says, every composite number can be expressed or can be factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Now, I'm going to take this one by one and we'll decode what this theorem exactly means. Now, what this theorem first tells us that we have to take some composite number. For example, if I take the number, let's just say 12. You can factorize this number 12 and you can write the factors. Mainly, we're going to prime factorize it. So, all the factors that we're going to write will be prime numbers. Now, if I start factorizing it, first I'll start dividing this by 2. So if I divide this by 2, I know 2 6 are 12. So I'll write down 6 right here. Next, I know that this is again even, so it will be again divisible by 2. So I'll take 2 again, and I know 2 3s are 6. And lastly, we have 3 1s are 3. So what I've simply done is 12 can be written as 2 into 2 into 3. And this, what I have done here is basically prime factorize 12. So 12 I have expressed in terms of prime numbers 2, 2 and 3. So if you take any random composite number, you can always express that composite number. You can always factorize that composite number as a product of some prime numbers. Now what is important is this prime factorization that we have done is a unique, meaning no other number will have the same set of prime numbers. For example, you can take 15. Now, if I prime factorize 15, I know 5 3s are 15 and 3 1s are 3. So, if you look, 15 has a completely different prime factorization. It is 5 into 3. So, no prime factors will be completely the same. Now, what can be different is you can change the order. For example, if instead of having 2 into 2 into 3, you can also write 3 into 2 into 2. So what I've simply done here is I've simply changed the order in which the prime numbers occur. But if you see, even if you change the order in which the prime numbers are occurring, you'll still get 12. So we'll just ignore the order for now, and what is only important is how many 2s do we have and how many 3s do we have. Another way to write this is we're going to write 3 raised to 1 to represent that there is only one 3, and since there are two 2s, I'm going to write 2 raised to 2. Okay. Now we'll look at some other couple of factorizations right here. Now I'll take the number, for example, 24. Now if I take the number 24, first of all it's an even number, so we'll start with 2. So if I take 2 first, I know 2 1s are 2, 2 2s are 4. Then I'll take maybe 2 again, because again 12 is a prime number, 12 is a even number. Then 2 6 are 12, again 2 3s are 6, and then 3 1s are 3. So the prime factorization of 24 is 2 into 2 into 2 into 3. Now since 2 occurs 3 times, I can write this as 2 raised to 3 into, and 3 is occurring only one time, so I'm writing it this as 3 raised to 1. This question is from exercise 1.1. The question, I'm starting with question number 1 here. The question number 1 says express each number as a product of its prime factors. So we simply have to prime factorize each of the following numbers right here. So the first one that I have here is question number 1. I'm starting with 140. So we'll quickly prime factorize 140. So if you see, this number is ending with 0, so it is going to be an even number. So we'll start with 2 first. So I have 2 7s are 14. I'll carry that 0 over. Then again, this is an even number, this is ending with 0, so you can do 2. Now I'll do 2 3s are 6, I'll carry 1 over, 2 5s are 10. Now this number ends with 5, it is 35, so I'm going to carry with 5 next. 5 7s are 35, and then 7 1s are 7. So the prime factors of 140, they are 2 into 2 into 5 into 7. So you can also write this as 2 raised to 2 into 5 raised to 1 into 7 raised to 1. Next, carry over to the next question that we have. I have 156. So we'll quickly prime factorize 156. Again, if you see this number is ending with 6, it is going to be a even number, so I'll start with 2. So 2 7s are 14, carry 1, 2 8s are 16. Again, ends with 8, so I'll start with 2. 2 3s are 6, carry over 1, 2 9s are 18. Now if you see, this number is not anymore an even number, so next we'll go with 3. 3 1s are 3, 3 3s are 9, and then since 13 is a prime number, I have to go 13 1s are 13. So 156 is going to be 2 into 2 into 3 into 13. If any one of you is wondering what a prime number is, I'll quickly go through that. I'll just write a couple of examples of prime number. We have 2, 3, 5, 7, 11, 13, we have 17, 19, I have 23, etc. So these are some couple examples of prime number. If you see, what is important with regards to prime number is, if you take for example 5. Now 5 comes in only the table of 5. We have 5 1s are 5. Or we have 13 1s are 13, 17 1s are 17, 19 1s are 19, 23 1s are 23. If you see all these numbers, they do not occur in any other table. See, 23 does not occur in any other table if you see. Similarly, 17 does not occur in any other table except table of 17. So these are known as prime numbers. Carrying over to the question number 3, the third question that we have right here is 3, 8, 2, 5. So we'll quickly prime factorize this one. Now if you see right here, this is ending with 5, so I'll start prime factorizing this by 5. Now if anyone has any doubts on how to prime factorize this way and has having a trouble, I'll quickly show you how to divide separately if you want. So 3, 8, 2, 5. We'll quickly divide by 5. So always remember, when you're dividing any number, you have to start with one number at a time. So we'll start first with 3. Now definitely 3 is not divisible by 5, so now we'll take the next number, which is going to be 38. So we know 5 7s are 35. So if you subtract this 35 minus 38, this is going to give you 3. Again, you can take down one number at a time. So we can bring only one number, which is 2 at a time. So I know 5 6 are 30. Again 2 is left here. So next I'll bring that 5 down. This is going to give me 5 5s are 25. So this answer is going to be 7 6 5. Again, if you see this number is ending with 5, so I'll again start dividing by 5. So the next division that we have is 7 6 5 divisible by 5. I'll do 5 1s are 5. If I subtract this, I'll end up with 2. Remember, you have to take one number down at a time, so we're only going to take 6 down. Now I know 5 5s are 25, so 1 remains. If I bring that 5 down, I'm gonna get 5 3s are 15. So that's it. So the next answer that we have is 153. Now if you see, this number is not ending with any even number. This is not ending with 5. This is not ending with 0. So we'll just quickly check whether this number is divisible by 3 or not. Now, how to quickly tell whether any number is divisible by 3? What you're gonna do is, we'll take the number 1, 5 and 3. Okay, now you add all the digits up, that is 1 plus 5 plus 3. We'll add the individual digits. This will end up giving you 9. Now we know that 9 is divisible by 3, right? Because if you divide 9 by 3, the answer is 3. Therefore, since this number is divisible by 3, this number will also be divisible by 3. So we'll start dividing this by 3. We have 3 5s are 15 and 3 1s are 3. Again, if you check the next number, which is 51, now if you add 5 plus 1, this is going to be 6. 6 is divisible by 3. So 51 is also going to be divisible by 3. So we have 3 1s are 3, 2 left behind, so we have 3 7s are 21. Now 17 is a prime number, so 17 1s are, this is the answer. So the prime factorization of 3 8 2 5 is going to be 5 into 5 into 3 into 3 into 17. So you can also write this as 5 square plus into 3 square into 17. We'll have a look at the next question, which is question number 4 here, which is 5005. So we'll quickly prime factorize this. Now, since this number is ending with 5, I'll start with the first number, 5. So 5 ones are 5. Those 2 zeros I'll note it down as itself, and 5 ones are 5. Now, if you see 1001 is a very weird number, right? It looks like it is not divisible by anything, and it looks like it's a prime number, but we'll quickly try. I'll just take 1001. And I'll start dividing it by different numbers. So I'll start divisible. It is definitely not divisible by 2 because it's not an even number. It is not divisible by 3 as well, because 1 plus 1 is going to give you 2. 2 is not divisible by 3. It's not going to be divisible by 5 nor by 7. We'll quickly try 7 first. So if you divide this by 7, we have 7 ones are 7. So 3 is left behind, so if you take that 0 down, 7 4s are 28. Now if 2 is left behind, if you take down that 1, we know 7 3s are 21. Done. So this is actually divisible by 7. The answer is 143. Now we'll quickly check with 143. If you see if you add 1 plus 4 plus 3, this is going to give you 8. 8 is not divisible by 3, so this is also not divisible by 3. We'll quickly check for 5. It's not divisible by 5. We'll check for 7. Now 7 2s are 14, so 3 is taken down. Again 3 is not divisible by 7, so again it's not divisible. We'll try with 11 next. If you do 143 divided by 11, I have 11 ones are 11. 3 is left behind, so I'll take the 3 down, so I know 11 3s are 33. So the answer is going to be 11 into 13. And then since 13 is a prime number, 13 ones are 13. So 5005 can be written as 5 into 7 into 11 into 13. Now for your exam, I'll suggest you to quickly put a star right here on your textbook, because for your exam, this is a little different type of question. So I want you to go through this question a day before the exam, or else you won't remember how to solve it. So anytime we come across any problem which is a bit different or which could not be solved properly, we're gonna be putting a star next to it, and I also want you to put a star next to it on your textbook. Going to the last question for this particular question number 1, we have 7 4 2 9. I'll quickly prime factorize this one, 7 4 2 9. Now it's not prime factorizable by 2 because it's not an even number. We'll quickly try with 3. Now to check whether this is divisible by 3 or not, I'll quickly add the numbers. 7 plus 4 plus 2 plus 9. This will give you 7 plus 4 is going to give you 11. 2 plus 9 is going to give you 11. So this is going to give you 22. Again 22, it is not divisible by 3, so again this number is not divisible by 3. Now we'll try with 7 next. So if you try and divide 7 4 2 9 by 7, we'll see what we're getting. So 7 ones are 7. Done. I'll take the 4 next down. Now remember, as I told you, you can only take down one number at a time. Now since if you see, we have taken down 4 down, but 4 is not really divisible by 7, right? So you have to take one extra number down, which is 2. Now when you're taking 2 numbers down at a time, you have to put 0 right here. Now we know 7 6 are 42. Again if you take that 9 down, I'm gonna have 7 ones are 7, but again 2 is going to be a remainder, so also this is not divisible by 7. We'll try the next one. We'll try 11 next. So we have 11 6 are 66. Carry over this one. This will be 6 left behind, so this is going to give you 8. Now if you take that 2 down, We know 11 sevens are 77. If you subtract this, this will end up going to give you 5. And if you take that 9 down, this is going to become 11 5s are 55. Again, if you see, 4 is left behind as a remainder. So also this is not working out. Next, we'll try 13 quickly. So if you take 7, 4, 2, 9, we'll quickly try and divide this by 13. Now I know 13 is a big table. Sometimes you might not know that or not know the table of 13 by heart. In that case, what I'll suggest you is to quickly write that table down at the side, so that would be helpful. Now we'll quickly do 13 5s are 65. If you subtract this, you have 9 left over. Then we'll take the 2 down. Next we have 13 7s are 91. Again 1 is left over. If you take that 9 down, you have 13 1s are 13. Again 6 is left behind as a remainder. So even this is not working out. So next number that we have to try with is 17. So we'll quickly do that. So next we'll quickly try dividing that by 17. So if you see, I've written the table of 17 at the side. So we have 17 4s are 68. If I subtract this, I'll get 4 6. I'll carry over that 2 down. That will next give me 17 4s are, or 17 3s are 51. This will give me 1 plus 1 11. I'll take that 9 down. This will give me 17 7s are 119. So we have found one answer. So we have got 7 4 2 9. The first factorization is 17 and it's not a even number. It does not end with 0 or 5. We'll check whether it is divisible by 3 or not. So we have 7437. If you add all these numbers together, 4 plus 3 plus 7, this is going to give you 14. Since 14 is not divisible by 3, this number also is not divisible by 3. We'll try dividing that by 7 next. If you do 7 6 are 42. 1 left behind, we have 7 2s are 14. Again, this is not divisible by 7. We'll try 11 next. So if you have 11 3s are 33. So we have 10 left behind. 11 9s are 90. 9 and 8 is left behind. Again, not divisible. So next we'll try with 13. We have 7. We have 13 3s are 39. So we have 4 left over. If you go to next, 13 4s are is 52. So again we'll do 13 3s are 39. So 8 is left behind, but 8 is not divisible by 13. So again this is gone. So if you see right here, 7429, it is not divisible by 7. It is not divisible by 11 nor by 13. So the next number that we have to try is definitely 17. So I'll quickly rub all of this together since we don't require this. Next I'll start dividing 437 by 17 next. So if you 17 2s are 34. So 9 is left behind. If I take that 7 down, I have 17 5s are 85. That will give you 12. Again 12 is not divisible by 17. So if you see, even 17 is not working out. So the next number that I'm going to try with is, I'm going to try dividing 437 by 19. Now I'll tell you a quick trick to remember the table of 19. To remember the table of 19, we'll just have a look at the table of 9. So for the table of 9, you're going to write this as 9 8 7 6 5 4 3 2 1 0, and then you're going to write this as 1 2 3 4 5 6 8 and 9. That's how you get the table of 9. Very interesting. You keep on adding plus 1 everywhere. Now to write the table of 19, again we're going to write 9 8 7 6 5 4 3 2 1 and 0, but here we're going to do a little different. We're going to add plus 2 everywhere. So if you see, 1 plus 2 is 3, 3 plus 2 5, 5 plus 2 7, 7 plus 2 9, 9 plus 2 11, plus 2 13, 15, 17 and 19. So that's how you get the table of 19. 1 2 3 3, 4, 5, 6, 7, 8, 9, 10. Now we'll quickly try and solve this answer right here. So we know 19 2s are 38. So if you subtract this, you're gonna end up with 5 next. If I take 7 down, I'm gonna get 19 3s are 57. So that's it. So this is going to be 19 into 23, and since 23 is a prime number, this is going to be 23 ones are 23. So the prime factorization of 7, 4 to 9, this is equal to 17 into 19 into 23. Now this is a very unique answer. So for this particular question, I want you to put a big fat star right there, just so you remember day before the exam that you have to practice this question. Okay. Thank you so much for watching this video, and I'll see you in my next one. Bye bye.